Hey everybody, this is Larry. This is me working on day 28 of the November Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this poem, which is 797, all paths from source to target. Okay, so given a DAG from 0 to n-1, find all paths and return them in any order. Oh, it is a DAG. I forgot the DAG for a second. Yeah, I mean, so the number of paths can be exponential, so you just have to kind of do it, right? There is so I think you could do it with breadth first search, you could do it with depth first search. Yeah, I mean, I think that should be okay, and there's no self loops because this is a DAG. And I think that should be okay. So let's just do a depth first search. So the thing that I would say is that this is going to be exponential in at worst, because that's just the number of paths, right? And because knowing that is going to be exponential, and some of this is experience and practice, knowing that it's going to be exponential will mean that you don't have to worry about finding a better solution, because it is just the way it is. Because you have to print it out, because you have to print them out. There's no shortcut of just counting or something like that, right? Because if you want to do counting, then it'll be dynamic programming or something. Yeah, probably just dynamic programming, right? And then I noticed that n is 15, and because the n is 15, the number of paths in this case will be, roughly speaking, at most, it's not a hard limit, but at most 2 to the 15, right? Because you can think about, you're only able to, there are 15 nodes, each node may be visited once or not, so you can think about that as 2 to the 15. Maybe 2 to 14 if you want to say that you always have to begin and you always have to end, so maybe 2 to 13, something like that. But anyway, it's just an upper bound, right? So because even 2 to the 15 is going to be fast enough for me to implement. In this case, it'll probably be 2 to the 15 times 15 or something like that, because you have to make a copy of the list or something. So that's basically all the things that I need to kind of get started on this one. So yeah, let's get started. Yeah, let's go to let's just say current, and because this is depth first search, we don't have to care about visited or anything like that. But or at least in terms of revisiting, but we could maybe current path, just go path then, right? If x is equal to n-1, then answer dot append path. One subtle thing that I would say, especially if you're a little bit new to Python, you need this part. But what basically this thing does is that it copies the array. It makes another copy of the array and then appends it. The reason why you can't just do this is because then the answer will keep on. It's a reference to the path and not the elements inside the path. So you would just keep on appending the same reference, and then you'll see answers where like all the elements are the same, and you're like, why? Well, because you didn't make a copy of it, and this is why. And it's okay if you make that mistake, because everyone has in Python, probably multiple times. In my case, it took me a long time to learn. So yeah. And then anyway, for I like to call it V because UV for graphs, but graph of X, as V path plus. Actually, in this case, I don't need this per se, but let's just be a little bit mindful. Right? Depth first search, was it 0? Yeah. Oh, yikes. Oh, I forgot to put 0 in here. Okay, that's an easy fix. Hopefully that's it. Also forgot to just put in more test cases anyway. Okay, so that looks good. Let's give it a submit. Apparently I did it a year ago. Hopefully this one's good too. Yep, 607 day. Yay, good warm up. But yeah, but like I said, this could be potentially exponential, but that's just gonna be the size of the output anyway. So you can't really do better than that. Yeah. this is going to be roughly speaking, like I said, n times 2 to the n, because we have to make this copy. So yeah, that's all I have for this one. Let me know what you think. Oh yeah, the reason why each node cannot be visited twice is because it's a DAG. So once you skip going somewhere, you just don't go back to it. So like there's no because there are no like, because it's a DAG, you cannot go, there's no like ABC and then AC. If ABC is in the graph, then ACB is not in the graph, right? So possible path. So yeah, anyway, that's all I have. Let me know what you think. I think the code is interesting, but if you get a little bit confusing about the analysis, let me know. But also maybe listen to this again. But yeah, because I think some of what I said is maybe a little bit subtle and I could draw on it more. But yeah, let me know. Anyway, stay good, stay healthy, to good mental health. Have a great rest of the weekend. Yeah, hopefully you're thankful. Maybe I should have done a thankful bit. I'm thankful for for over this weekend, and thankful for you viewers at home. So yeah. Anyway, maybe I'll do a real one later. It just came to me. Anyway, stay good, stay healthy, to good mental health, and take care. Bye bye.